All right, so Unit 7 is about similarity, and it's kind of related to congruences, and you'll see some familiar theorems that we use for congruencies, and we'll apply those for similarities as well. So instead of having you guys do this activity while I'm gone, we're just kind of going to fill in the table and go from there. So what the idea is, we have two pictures down here of sailboats where you got photo 1 and then photo 2 is a reduction of this. So what I went ahead and did is I measured the lengths of these segments in both photos, and let's fill those in real quick. For AB in photo 1, that was 76 millimeters. AC was 28 millimeters. DE was 57 millimeters. And the angles, I used a protractor to measure, and I got 60 degrees and then 26 degrees. Now in photo 2 is down here. I measured again AB, and that was 43 millimeters. AC was 16 millimeters. DE was 32 millimeters. The measure of angle 1 was still 60 degrees, and the measure of angle 2 was still 26 degrees. So then this third column says take the measurement of photo 2 and divide it by the measurement of photo 1. So I'm going to take this number divided by this number. So that's 43 divided by 76, and that's 0.57. Then we have 16 divided by 28, that's also 0.57. We have 32 over 57, and that's 0.56. So your numbers might have been off slightly if we were doing this activity, just because of rounding and because counting millimeters on a ruler is incredibly tedious, and they're small, so it might be difficult to get an exact measure. All right, so now for angles, 60 over 60 is 1, and 26 over 26 is also 1. So before we look at the next page, let's look at some things that we see. Well, when it comes to side lengths, the ratio was the same or pretty close to being the same ratio when we divided the two. And it was a decimal smaller than 1. When we look at angles, the ratio was 1 for both angles. So now we're going to use this information to draw some conclusions on the next page. So let's look at the next page, please. All right, so we're asked to make a conjecture about the relationship between corresponding lengths when a figure is reduced. A conjecture is just an educated guess. And let me spell that right. So kind of like a hypothesis in science class, where you look at some evidence and you make a guess about it. So looking at the lengths, the corresponding sides had the same ratio when we reduced them. If you look at their picture, we have AB in one triangle and AB in another triangle, and those sides corresponded with one another. So when a figure is reduced, when a figure is reduced, the corresponding lengths, so we can abbreviate corresponding. Are proportional. Now, make a conjecture about the relationship between corresponding angles. Well, the angles were the same in each figure. So the corresponding angles are congruent. Remember, corresponding just means that it matches up. So angle 1 and angle 1 in each picture are corresponding. All right, let's look at number 3. Suppose a measure of an angle in photo 2 is 35. What is the measure of the corresponding angle in photo 2? Or sorry, photo 1? Well, we just said that the corresponding angles are congruent, so if the measure of an angle in photo 2 is 35, then the corresponding angle in photo 1 should also be 35 degrees. Now, suppose a segment in photo 2 is 1 centimeter long. What is the measurement of the corresponding segment in photo 1? Well, remember, photo 1 is the bigger photo. Photo 2 was the reduction. So we know we should be able to think and say, well, in photo 2, if it was 1 centimeter long, that means in photo 1 it should be bigger than 1 centimeter. So what we'll do is we'll take our length from photo 2, so 1, and we're going to divide it by this ratio from the previous page. And we're going to use 0.57 since we got that twice. So we're going to do 1 divided by 0.57, and that equals 1.77. And the units they used here was centimeters, so do the same thing here. And number 5, suppose a segment in photo 1 is 5 centimeters long. What is the corresponding segment in photo 2? Okay, so we're going from photo 1 to photo 2. Remember, photo 2 is the shrunken photo. So what we will do is take that 5 and multiply it by that 0.57 ratio. We get 2.82 centimeters. I know that can kind of be confusing because number 4, we were going from the big, small picture to the big picture, but we divided. And in number 5, we're going from the big picture to the smaller picture, and we multiplied. So you just got to kind of remember that, and always think if your answer makes sense. If you would have done this backwards, if you would have done 5 divided by 0.57, you would have gotten a number that's bigger than 5. You would have gotten 8.77. And that shouldn't make sense because photo 2 is a smaller photo. So the corresponding length should be smaller than 5. So you can kind of use that to see if you're doing this correct or not. All right, let's look at the next page, please. All right, in Unit 2, we talked about dilations a little bit, which was either an enlargement or a shrink of a shape at that point. So remember the rule for dilations, if we have a point, x comma y, that becomes k times x times k times y. We multiply the x and y values by that scale factor, which is also known as our k value. So this may be a little bit of review from before, just to kind of get our heads back into dilations, because when you dilate an image, you're actually creating another image that is similar to the original. So let's look at these examples. Right, so this example says construct a dilation of a segment in the plane with center of dilation at the origin. We'll talk about dilations not at the origin later. We have triangle ABC, and we're going to dilate that by a factor of 3 from the origin. So what I would do first is find the coordinates of A, B, and C. A is 2, 3. B is 1, 5. And C is 5, 4. So now we're going to multiply each coordinate by our scale factor, which was 3, given to us in the original problem. So A prime, remember that this notation is called A prime. 2 times 3 is 6. 3 times 3 is 9. 1 times 3 is 1 times 3 is 3. 5 times 3 is 15. Then multiply the x and y by 3. We get our points. So then we can plot those points. So 1, 2, 3, 4, 5, 6. Okay. There is A prime, B prime, 3, 15. So this is B prime. And then C prime is 15, 12. So there is C prime. So this is our dilated triangle. And what's happening here is that the distance from our origin, which is our center of dilation, the distance from 0 to B, and the distance from the origin to B prime, is by a scale factor of 3. So if I multiply the distance from the origin and B, so if I multiply the distance from the origin to B by 3, that gives me the distance from the origin to B prime. If I multiply the distance from the origin to C, if I multiply that by 3, that would give me the distance from the origin to C prime. And that's only because our dilation center is at the origin. So now let's look at example number 2. This one says a scale factor of 0.5 from the origin. So after we get our coordinates, we're going to multiply each value by 0.5. So A is 6, 8. B is 3, 15. And C is 16, 10. So I'm going to multiply each value by 0.5, which is the same thing as 1/2. So then this will be 3, 4. This will be 1.5, 7.5. And this will be 8, 5. So we can plot those points now. 3, 4. This is A prime. B prime 1.5, 7.5. That's B prime. And then 8, 5 will be C prime. And this is our reduced triangle. So now what we could do, our dilation center is at the origin. The distance from the origin to B, if we calculated that distance and cut that in half, that would be the distance from the origin to B prime, because our scale factor was 0.5 or 1/2. So that center of dilation does play a factor into these distances here. So now let's go down here and get some properties of dilations written down. So we have two main properties of these dilations. First one, corresponding sides are proportional. And where proportional means that you can write them as a fraction. Proportion is a fraction. The next property is corresponding angles are congruent. And now the last one is kind of wordy, and it makes sense more from the pictures above than from writing. The coordinates of the image will move closer to the origin if k is less than 1 and further from the origin if k is greater than 1. So like in our examples up above, when k was 3 in example number 1, we saw that the points a prime, b prime, and c prime moved further away from the origin. And then example 2, when k was 0.5 or 1/2, the image b prime, c prime, and a prime moved closer to the origin or a center of dilation. All right, so I hope that this was a good kind of refresher into dilations and a good introductory lesson into some of the vocabulary we will be using. We'll hit more on this tomorrow. So you guys get started on your homework, and good luck. I will see you guys soon.